Everything you thought you knew about the largest flying animal in Earth's history? Complete fantasy. 2024 research just obliterated 50 years of scientific assumptions. Quetzalcoatlus wasn't some graceful prehistoric bird gliding peacefully over dinosaur herds. It was something far more nightmarish. A giraffe-sized apex predator that stalked the ground on folded wings, jaws long enough to swallow a human child whole, a wingspan stretching wider than an F-16 fighter jet. Then it vanished, left behind nothing but fragmentary bones scattered across Texas badlands and questions deep enough to haunt paleontologists for decades. How did something that massive actually fly? What did it eat? Because here's what'll keep you up tonight. More disturbing than discovering a flying creature the size of a small plane existed is realizing we never understood it at all. And the new evidence, we weren't just slightly off. We were catastrophically wrong about its size, its lifestyle, even how it moved. Quetzalcoatlus might have been dramatically different and monumentally more terrifying than anyone imagined. Let's rewrite history. Picture a shadow passing over you, not a cloud. Something with wings, 11 meters across, the length of a city bus. It blocks out the sun for 3 full seconds. Then it lands, and it's taller than you are. Sounds like dragon mythology, right? Except it's not. And the proof started with a graduate student wandering through Big Bend National Park in 1971. Douglas Lawson was mapping geological formations when he spotted something impossible. A hollow bone jutting from ancient sediment. Not just any bone, a wing bone. Massive, unlike anything in the fossil record. He'd stumbled onto the first evidence of Quetzalcoatlus northropi, named after the Aztec feathered serpent god Quetzalcoatl and aircraft designer Jack Northrop, who pioneered flying wing aircraft. The name itself hints at the creature's impossible nature. Part god, part machine. But here's the problem that would haunt science for half a century. Lawson found fragments, partial wing bones, a few vertebrae, nothing complete. From those scraps, paleontologists had to reconstruct an entire animal, and they got it spectacularly wrong. Early reconstructions imagined Quetzalcoatlus as an oversized pelican. Long neck, tiny body, spindly legs. Scientists assumed it skimmed ocean surfaces, scooping fish like modern seabirds. The image was almost elegant, peaceful, a gentle giant of the Cretaceous skies. The problem? Zero evidence supported this. None. It was pure assumption based on what we knew about modern flying birds. Pterosaurs aren't birds. They're not even related to birds. They're an entirely separate lineage of flying reptiles that evolved flight 80 million years before birds existed. Comparing them to pelicans is like comparing dolphins to sharks because both swim. 1995 changed everything. Paleontologist Thomas Lehman discovered additional Quetzalcoatlus specimens in Texas. Smaller individuals, more complete skeletons. Suddenly, scientists had actual data to work with. What they found shattered the pelican theory completely. Quetzalcoatlus had a neck over 2 meters long, stiff, rod-like, terrible for fishing. Its jaws were straight and pointed, lacking the scooping mechanism found in fish-eating pterosaurs. Its teeth? Completely absent. A massive toothless beak that couldn't grip slippery prey. Even more damning, the geological evidence. Quetzalcoatlus fossils appeared in inland formations, hundreds of kilometers from any Cretaceous coastline. No marine sediments, no fish fossils nearby, no indication this creature ever touched an ocean. The skim-feeding hypothesis collapsed overnight. So, if Quetzalcoatlus wasn't fishing, what was it doing? Dr. Mark Whitten and paleontologist Darren Neisch proposed something radical in 2008, ground-stalking. They argued Quetzalcoatlus spent most of its time walking, not flying, hunting on foot like a terrestrial predator. The biomechanics supported this. Quetzalcoatlus had incredibly robust forelimbs. When folded, its wings became powerful walking limbs. Its hind limbs were proportionally long and strong. This wasn't an animal that flopped helplessly on land. It strode, confidently. Head held 5 meters above the ground, scanning for prey. Picture a creature combining the height of a giraffe, the predatory instincts of a stork, and the wingspan of a Cessna. Now picture it walking toward you. This is where reconstructions got disturbing. Whitten compared Quetzalcoatlus to modern ground storks and marabou birds, animals that hunt by walking through environments, striking at anything small enough to swallow. Dinosaur hatchlings, small mammals, lizards, carrion, that massive toothless beak, perfect for grabbing and gulping prey whole. No chewing, no tearing, just seize and swallow. Analysis of its skull revealed forward-facing eyes, binocular vision, depth perception specifically evolved for tracking prey. This wasn't some passive filter feeder, it was an active hunter. But we still didn't understand the most impossible part. How did something weighing 250 kilograms get airborne? For decades, the math didn't work. Modern physics suggested 40 kilograms was the upper limit for powered flight. Above that, the energy requirements become impossible. Wing loading, weight distributed over wing area, increases exponentially with size. Muscles can't scale fast enough to compensate. Quetzalcoatlus exceeded the theoretical maximum by 600%. Scientists proposed embarrassing solutions. Maybe it only glided. Maybe it launched from cliffs. Maybe the weight estimates were wrong. They were wrong, just not in the direction anyone expected. 2010 brought revolution. Biomechanist Michael Habib recalculated everything from scratch. He discovered previous models used bird-based assumptions. Fatal error. Pterosaurs weren't birds. Their anatomy operated on completely different principles. Birds launch using their legs. Pterosaurs launched using their arms. Habib demonstrated that Quetzalcoatlus crouched on all fours, then explosively vaulted using its massive forelimbs, essentially performing a push-up powerful enough to throw a 250-kilogram body into the air. Those robust wing bones weren't just for walking. They were catapult springs. Computer simulations showed this quad launch could generate enough initial velocity to become airborne in under a second. No runway needed, no cliff required, just raw explosive power. Once airborne, Quetzalcoatlus exploited thermals with ruthless efficiency. Its enormous wingspan created exceptional lift-to-drag ratios, like a hang glider scaled up to nightmare proportions. Soaring required almost zero energy expenditure. Flight range estimates? Over 16,000 kilometers non-stop, theoretically capable of crossing oceans without landing. A single individual could patrol territories the size of Texas. Before we go further, if you're the kind of person who finds prehistoric nightmares irresistible, hit subscribe and turn on notifications. What's coming next about this creature will make everything so far look tame. Trust me, you'll want to see where this goes. The new biomechanical model solved flight, but it created another problem, one that exposed how wrong our reconstructions truly were. If Quetzalcoatlus could launch so powerfully, if it had such robust limbs, if it walked so effectively, then previous body mass estimates must be catastrophically low. 2019 research from Dr. Elizabeth Martin Silverstone dropped a bomb. She analyzed pterosaur bone density using CT scanning technology unavailable to earlier researchers. What she found? The bones were even more hollow than assumed. Paper-thin walls surrounding air spaces. Previous estimates assumed 250 kilograms. New calculations suggested 200 to 260 kilograms for large individuals. Some researchers pushed lower, arguing 150 kilograms possible for the largest specimens. Here's why that matters. A 150 kilogram predator standing 5 meters tall with an 11-meter wingspan changes everything about how we imagine this animal. It wasn't a lumbering giant, it was disturbingly light, almost skeletal, built entirely around the singular purpose of flight. Imagine a hollow puppet the size of a giraffe. That's the new Quetzalcoatlus. Something that looks impossibly large but weighs less than an adult male gorilla. The proportions become almost alien, and we still haven't addressed the most controversial question. What exactly was it eating? The ground-stalking model works beautifully. Quetzalcoatlus marching through Cretaceous floodplains, snapping up whatever it could swallow. But 2021 research complicated everything again. Paleontologist Brian Andres led a study examining feeding trace fossils, evidence of actual pterosaur meals preserved in stone. What he found didn't match the predator narrative. Multiple hatchlings pterosaurs, the family containing Quetzalcoatlus, showed evidence of consuming soft-bodied invertebrates, worms, grubs, burrowing creatures pulled from mud. The giant terrestrial stalker might have been probing for earthworms, not exactly the apex predator image, but it makes ecological sense. Large-bodied animals need consistent food supplies. Hunting baby dinosaurs sounds dramatic but provides unreliable calories. Mud probing guarantees steady nutrition. However, and this is critical, Quetzalcoatlus itself hasn't yielded direct feeding evidence. The worm-eating pterosaurs were smaller hatchlings. Whether the giant followed the same strategy remains unknown. Some researchers argue the largest individuals must have supplemented with larger prey. Carrion scavenging, opportunistic predation. A creature that large couldn't survive on insects alone. The debate continues. What's not debated? Quetzalcoatlus dominated late Cretaceous North America. Fossils appear across Texas, Montana, and Alberta. This wasn't a rare freak of nature. It was a successful apex flyer that thrived for millions of years, until it didn't. 66 million years ago, the asteroid. Quetzalcoatlus vanished alongside the non-avian dinosaurs. Every pterosaur species went extinct. After 150 million years of aerial dominance, the entire lineage ended in geological instance. But here's what haunts researchers. Pterosaurs were declining before the impact. Diversity had dropped throughout the late Cretaceous. Some scientists argue they were already doomed, outcompeted by evolving birds, stressed by changing climates. Others disagree violently. They point to Quetzalcoatlus as proof pterosaurs remain viable. You don't evolve the largest flying animal ever if your lineage is failing. The truth? Probably somewhere between. Pterosaurs were vulnerable. The asteroid delivered the killing blow, and with their extinction, something irreplaceable vanished from Earth. No bird has ever approached Quetzalcoatlus proportions. Nothing ever will. The physics that allowed pterosaur gigantism required specific anatomical innovations that birds never developed. The quad launch, the hyperneumatic skeleton, the wing membrane structure. Evolution doesn't repeat. It can't. Quetzalcoatlus represented a unique solution to flight that existed for 150 million years and will never exist again. So, there we have it. Our journey back to the true age of giant flyers and one of the most magnificently monstrous beings ever to take wing comes to an almost humbling end. Something so alien and powerful feels like it deserves to soar forever against prehistoric skies. Instead, the reality is abrupt. Asteroid, darkness, extinction. Despite that, Quetzalcoatlus remains endlessly intriguing. It seems fitting that something so impossible kept secrets for 50 years after discovery. Yes, we now understand it better. The ground-stalking predator, the quad-launching flyer, the hollow nightmare standing taller than any bird imaginable. But mysteries remain. We've never found a complete skeleton. Not one. Everything we know comes from fragments, extrapolations, educated guesses refined by technology and imagination. The skull shape, reconstructed from partial remains. The feeding strategy, still debated. The exact weight, controversial. Every few years, new fossils emerge. New techniques reveal new details. New papers overturn old assumptions. The Quetzalcoatlus we imagine in 2030 will probably embarrass our current reconstructions. That's science. That's paleontology. Building dragons from scattered bones and then watching them transform as evidence accumulates. 50 years ago, we pictured a giant pelican. Today, we picture a giraffe-stork hybrid capable of intercontinental flight. Tomorrow, who knows what this creature becomes? But one thing remains certain. Something with an 11-meter wingspan walked the same Earth that spawned humanity. Something that defied every physical limit we thought governed flight. Something that looked like mythology made flesh. Quetzalcoatlus existed. and we're only beginning to understand what that means. Everything you thought you knew about the largest flying animal in Earth's history. Complete fantasy.